my name's Ed, and this is the 5C Harding collet repair part that I manufacture. This is a typical lathe that uses a 5C collet. In this case, it's a nice original equipment lever action collet assembly made by Harding. The whole assembly comes off rather easily. You just pull the pin and pull the draw tube out. And here's the repair that I made about 5 years ago, and it's still in excellent condition. This is a typical 5C lever action collet closer, and it's no good because the threads are completely worn out in here. Here's a 5C collet. You can see somebody really stripped them out, and it's completely unusable, and I'm going to demonstrate on this how to repair this and make it good as new. It's not really necessary, but this lever part here is just in the way, so we'll get rid of it and try to make it a little bit easier. This makes it a little bit easier to work with, and you don't have all of that stuff in your way. This is the next operation here. What we have to do is we need to take exactly an inch off of the length of this thing, and we're going to scribe this real deeply so we have a good reference mark. We don't want to lose the length of this thing. Now what I've done here, I put some red Dykem on here. It's not necessarily, you don't have to do that, but it makes everything easier to see. Now there's a number of ways you can mark this. The simplest way is to get a square with 1 inch sticking out and make a good deep line all the way around there. You don't want to lose that. However, I have a little surface plate here with a scriber gauge on there, and I'm going to make a good deep scribe line all the way around there at exactly 1 inch. You don't have to have this, but it's very important however you do it to make a good deep line. You don't want to lose that. The next operation is to get rid of this excess piece here. There's a number of ways you can do it. Get a good sharp hacksaw and watch your line. You don't want to cross the line. You want to leave the line. Most of these things are pretty soft. You can go ahead and saw this off if you want to. You could put it in your cut-off bandsaw. You could do it any number of ways. You could use an abrasive saw. I'll probably put it in the lathe and cut it off with a lathe tool bit. But however you do it, you just want to get rid of most of the excess material. You want to leave the line. You don't want to cut into the line. Here I have my drawbar chucked up in my lathe, and I have a little steady rest here, and I have completed cutting it off. Here's the little part right there, and at any rate, it's all running true. It went real good. I have a nice little digital readout on my stop here, and let's see, it cut it off at 998 thousandths. That's plenty close, and it's all good. Here's the piece that I just cut off with the bad threads in it. So that's all for this operation. The next operation is to bore your hole to size, which I've done. Now if you're welding, you just want a nice snug fit, such as right there. However, if you're going to silver solder, like I'm going to do, you want an additional 2 thousandths per side clearance for the silver solder. So I'm going to do that now. Now I've given the extra 2 thousandths per side. It's nice and loose. The whole finish is somewhat rough, but that's good. That gives the silver solder a little extra tooth. Not a problem. The next operation is very important but it's easy. You must clean the draw tube and the part very good. You must use acetone or denatured alcohol or whatever cleaner you have that does not leave a greasy residue, and you especially do not want any grease left inside of this tube where the vapors will come up and ruin your silver soldering. The next operation is to mark the tube at 90-degree intervals, front and back and side and to the other side. And it's not real precision, but what you're doing is making 90-degree marks. And if you're silver soldering, you're going to take any kind of a file and make a notch here and here and here and here to feed the silver solder in. Now if you're welding, you would want to tack it in the front and tack it in the back, and then you would want to tack it on each side and let it cool in between time, and then fill in the weld, front and back and side the same way. Try not to get the tube extremely hot if you're welding it, because it's a thin tube. You take your time. Now I've notched the part and applied the silver solder flux that I supply if you order the part with the silver solder in it. I have a piece of threaded rod going through it with a washer, and the same thing all the way through, and that holds it all together, and the whole thing's clamped in the vise. And you want it vertical, you want the repair part up so that none of the flux or anything will have a tendency to go up and get into the threads. So we're getting ready to silver solder it now, and here is the flux and the silver solder that I supply. There'll be plenty of silver solder. It just takes very little to do this. Now I'm silver soldering this together. I'm going to have to turn this off in a minute while I do it. I would not recommend trying to do this with a Bernzomatic torch. You pretty much need an acetylene torch in order for this to work. If you don't have an acetylene torch and you don't want to do it, just take it to a welder. A good welding shop would be able to weld this up for you in the minimum charge, whatever they charge. It would only take a few minutes for a welder to weld this up. So like I say, I'm going to go ahead and solder this now. Here it is cooling off. The solder sucked right in there. Actually, I applied it on one side and I went over to apply it to the other side, and it was already there. So I put some more in and went all around it, heated the whole thing up, and it looks like there's no problem here. I'm going to let it cool off now. Here the part is cooled off real well, and as you can see, there's a good bead of solder around there, and it's coming out in all the holes. I didn't have to do this, but I'm going to stick it back in the lathe and pretty it up a little bit. And here's the part all prettied up real nice. It's looking good. And here's the collet. Ready to screw back in all the way. Everything's working good, and it's ready for another 30 or 40 or 50 years of use, or however long it takes.